Conduit is typically specified by its trade size, which is not the actual inner diameter of the conduit. Trade sizes are a historical holdover from the days when conduit was made from iron or steel and the inner diameter varied slightly with the thickness of the pipe wall. To compensate for the variations in wall thickness, a system of nominal sizes was developed. The nominal size of a conduit is approximately the same as the inner diameter of the iron or steel conduit it was meant to replace. Over time, the wall thickness of conduit has been reduced to save on material costs, while the trade sizes have been retained. The discrepancy between the trade size and actual size of conduit exists for several reasons. Firstly, historical precedent. Trade sizes were established when conduit was predominantly made from iron or steel. Changing the system to reflect the smaller actual sizes would have caused confusion and compatibility issues with existing installations. Secondly, backward compatibility. Conduit fittings and accessories are designed to fit specific trade sizes. If the actual size of conduit were changed, it would require the redesign and replacement of numerous components. Thirdly, simplification. Trade sizes provide a convenient way to specify and understand the size of conduit needed for a particular application. They eliminate the need to calculate actual diameters for each installation. The discrepancy between trade size and actual size has several implications for electrical installations. Firstly, capacitance calculation. Capacitance of a conduit system is affected by the actual inner diameter of the conduit. Using trade sizes to estimate capacitance can lead to inaccuracy. Secondly, wire pulling. The actual inner diameter of the conduit determines the ease of pulling wires through it. Smaller actual sizes may make it difficult to pull wires without damaging them. Thirdly, conduit fill. The amount of conduit that can be filled with wires is determined by the actual inner diameter. Overfilling a conduit can cause overheating and damage to the wires. To address these issues, it is important to use the actual inner diameter of the conduit when performing calculations and selecting components. Reference tables or online calculators can be used to determine the actual inner diameter for a given trade size. For example, a 1/2 inch trade size conduit does not have an inner diameter of 1/2 inch. The actual inner diameter is less. Likewise, a 3/4 inch conduit will not have the actual inner diameter. It will be more or less. This difference matters when calculating conduit fill, which is the percentage of the conduit's cross-sectional area that is occupied by conductors. The National Electrical Code, or NEC, specifies the maximum allowable fill for different types of conduit and wiring configurations. If you overestimate the inner diameter of the conduit, you may end up exceeding the allowable fill, which can lead to overheating and other problems. The NEC dictates the maximum percentage of conduit fill allowed, depending on the number of conductors within the conduit. For instance, for 3 or more conductors, the maximum fill is typically 40%. This 40% rule means that the total cross-sectional area of the conductors, including insulation, must not exceed 40% of the conduit's internal area. To accurately calculate conduit fill, you need to know the actual inner diameter of the conduit and the cross-sectional area of each conductor. Conductor area is usually found in NEC Chapter 9, Table 5a. This table lists the dimensions and cross-sectional areas for various types and sizes of conductors. After determining these values, calculate the total area occupied by the conductors and compare it to the conduit's inner area. If the conductor area exceeds 40% of the conduit area, a larger conduit size is required. The type of insulation on the conductors also affects the conduit fill calculation. Some types of insulation are thicker than others, so conductors with thicker insulation will take up more space in the conduit. The NEC specifies different conduit fill requirements for different types of conductors. When pulling conductors through conduit, friction can be a significant issue, especially in long runs or when there are multiple bends. The force required to pull conductors increases with the length of the run, the number of bends, and the weight of the conductors. To reduce friction, use pulling lubricants specifically designed for electrical conductors. These lubricants reduce the coefficient of friction between the conductors and the conduit, making it easier to pull the wires through. The NEC also specifies requirements for the number of bends allowed in a conduit run. Generally, the total number of bends between pull points should not exceed 360 degrees. Exceeding this limit can make it difficult to pull conductors and can damage the insulation. When installing conduit, proper support is essential to prevent sagging or damage. The NEC specifies requirements for conduit support based on the size and type of conduit, as well as the spacing between supports. Horizontal runs of conduit must be supported at intervals not exceeding those specified in the NEC. Vertical runs must also be supported, with the support intervals depending on the height of the run. Using the correct type of conduit for the application is also crucial. Different types of conduit are designed for different environments and applications. For example, rigid metal conduit, or RMC, is suitable for use in harsh environments where mechanical protection is required. Electrical metallic tubing, or IMT, is lighter and easier to bend than RMC, making it suitable for use in concealed locations. PVC conduit is non-metallic and resistant to corrosion, making it ideal for underground or wet locations. Consider the environmental conditions, mechanical stress, and potential for corrosion when selecting the appropriate type of conduit. Grounding and bonding are critical aspects of electrical safety, and proper conduit installation plays a vital role. Metal conduit systems must be properly grounded to provide a path for fault current to return to the source. This helps to prevent electrical shock and reduce the risk of fire. The NEC specifies requirements for grounding and bonding of conduit systems, including the use of grounding bushings, bonding jumpers, and other hardware. Always follow the NEC requirements and local codes when installing and grounding conduit systems. The size and type of conductors used in a conduit system must be compatible with the circuit's voltage and current requirements. The NEC specifies the allowable ampacity of conductors based on their size, insulation type, and temperature rating. Using conductors that are too small for the circuit's current can lead to overheating, insulation damage, and potentially a fire hazard. Always consult the NEC to determine the appropriate conductor size for the application. When making connections to conduit, use fittings and connectors that are specifically designed for the type of conduit being used. These fittings provide a secure and reliable connection between the conduit and other components, such as junction boxes, enclosures, and equipment. Use the correct tools and techniques when installing fittings to ensure a proper connection. Over-tightening or under-tightening fittings can compromise the integrity of the conduit system. The NEC requires that all electrical work be performed in a neat and workmanlike manner. This includes conduit installation. Runs of conduit should be straight and parallel, and all fittings and support should be properly installed. Avoid sloppy or haphazard installations that can create safety hazards or impede future maintenance. Adhering to these practices ensures a safe and reliable electrical system. Remember to consult the NEC and local codes for specific requirements and guidelines related to conduit installation. The NEC is updated every 3 years, so it's important to stay current with the latest edition. Continuing education courses and training programs can also help to improve your knowledge and skills in electrical work. The difference between the trace size and the actual inner diameter is due to the manufacturing process. Originally, conduit was made from thick-walled steel, and the trade size was close to the actual inner diameter. As manufacturing techniques improved and thinner walls conduit became more common, the trade size remained the same, even though the actual inner diameter increased. The trade size is a nominal size, meaning it is a reference point rather than a precise measurement. This makes it easier to specify and order conduit, as everyone knows what a 1-inch conduit, for example, is, even if the actual inner diameter varies slightly. The actual inner diameter of conduit is important for calculating conduit fill, which is the percentage of the conduit's cross-sectional area that is occupied by conductors. The NEC specifies the maximum allowable fill for different types of conduit and wiring configurations. Overfilling a conduit can lead to overheating and other problems. The actual inner diameter of conduit is also important for determining the proper size of pulling equipment. When pulling conductors through conduit, it is important to use equipment that is sized appropriately for the conduit and the number of conductors being pulled. Using undersized equipment can damage the conductors or the conduit. The NEC provides tables and guidelines for selecting the proper size of pulling equipment. In addition to the NEC, there are other standards and regulations that may apply to conduit installation. These include standards from organizations such as the Institute of Electrical and Electronics Engineers, or IEE, and the National Electrical Manufacturers Association, or NEMA. It is important to be familiar with all applicable standards and regulations before beginning any conduit installation work. Conduit comes in various materials, each with its own characteristics and applications. Steel conduit is strong and durable, making it suitable for use in exposed locations where it may be subject to physical damage. Aluminum conduit is lighter than steel and is resistant to corrosion, making it a good choice for outdoor applications. PVC conduit is non-conductive and resistant to chemicals, making it suitable for use in corrosive environments. The choice of conduit material depends on the specific application and the environmental condition. Conduit is available in different types, including rigid metal conduit, electrical metallic tubing, intermediate metal conduit, and flexible metal conduit. Rigid metal conduit, or RMC, is the heaviest and most durable type of conduit. It is typically used in exposed locations where it may be subject to physical damage. Electrical metallic tubing, or IMT, is a lighter and less expensive type of conduit. It is typically used in concealed locations. Intermediate metal conduit, or IMC, is a type of conduit that is similar to RMC but is lighter and less expensive. Flexible metal conduit, or FMC, is a type of conduit that can be bent easily. It is typically used to connect equipment that vibrates or moves. The type of conduit used depends on the specific application and the environmental conditions. When installing conduit, it is important to use the proper tools and techniques. This includes using a conduit bender to bend the conduit to the desired shape, a conduit reamer to remove burrs from the cut ends of the conduit, and a conduit fish tape to pull the conductors through the conduit. Using the proper tools and techniques ensures a safe and professional installation. When connecting conduit to boxes and enclosures, it is important to use the proper fittings. These fittings provide a secure and watertight connection between the conduit and the box or enclosure. There are different types of fittings available for different types of conduit. It is important to use the correct fitting for the type of conduit being used. When grounding conduit, it is important to follow the requirements of the NEC. The NEC requires that all metal conduit be grounded to provide a path for fault current to return to the source. This helps to protect people from electrical shock. There are different methods for grounding conduit. It is important to use the correct method for the type of conduit being used. When supporting conduit, it is important to use the proper supports. Conduit supports are used to hold the conduit in place and to prevent it from sagging. There are different types of conduit supports available. It is important to use the correct support for the type of conduit being used and the location where the conduit is being installed. When installing conduit in wet locations, it is important to use watertight fittings and seals. This helps to prevent water from entering the conduit and damaging the conductors. There are different types of watertight fittings and seals available. It is important to use the correct fitting and seal for the type of conduit being used and the location where the conduit is being installed. When installing conduit underground, it is important to bury the conduit at the proper depth. The NEC specifies the minimum depth at which conduit must be buried. This helps to protect the conduit from damage. It is also important to use the proper type of conduit for underground installation. When installing conduit in hazardous locations, it is important to follow the requirements of the NEC. The NEC defines hazardous locations as locations where there is a risk of explosion or fire. There are different types of hazardous locations. It is important to use the correct type of conduit and fittings for the type of hazardous location where the conduit is being installed. When working with conduit, it is important to follow all safety precautions. This includes wearing safety glasses, gloves, and other protective equipment. It is also important to be aware of the hazards associated with electricity. Always disconnect the power before working on any electrical equipment. Remember that electrical work can be dangerous. It is important to be properly trained and qualified before working on any electrical equipment. If you are not comfortable working on electrical equipment, it is best to hire a qualified electrician. The discrepancy between trade size and actual size is also important for conduit bending. When bending conduit, the bending radius must be sufficient to prevent damage to the conduit and the conductors inside. The minimum bending radius is typically specified by the conduit manufacturer and is based on the trade size of the conduit, not the actual inner diameter. Using the wrong bending radius can result in kinks or flattening of the conduit, making it difficult or impossible to pull conductors through. The type of conduit bender used can also affect the quality of the bend. Hand benders are suitable for smaller conduit sizes, while larger sizes may require hydraulic or electric benders. Proper technique is essential to achieve smooth, uniform bends without damaging the conduit. Another consideration is the spring back of the conduit after bending. Conduit tends to spring back slightly after being bent, so it's necessary to overbend it slightly to achieve the desired angle. The amount of spring back varies depending on the type of conduit and the bending radius. Some conduit benders have built-in features to compensate for spring back. Proper planning is essential for a successful conduit installation. Before starting the job, it's important to carefully plan the route of the conduit, taking into account any obstacles or obstructions. This includes determining the number and type of bends required, as well as the location of supports and fittings. It's also important to consider the accessibility of the conduit for future maintenance or modifications. A well-planned installation will save time and effort and will result in a more professional-looking job. Conduit systems must be properly sealed to prevent the entry of moisture, dust, or other contaminants. This is especially important in wet or corrosive environment. Sealants and sealing fittings are available for various types of conduit and application. The choice of sealant depends on the specific environmental conditions and the type of contaminants that need to be excluded. Proper sealing not only protects the conductors and equipment inside the conduit, but also helps to prevent corrosion of the conduit itself. In addition to the NEC, local codes and regulations may also apply to conduit installation. These codes may have specific requirements for conduit type, size, support, and grounding. It's important to check with the local building department or electrical inspector to determine the applicable codes and regulations before starting any conduit work. Compliance with local codes is essential for ensuring the safety and legality of the installation. When making conduit connections, it's important to use the correct type of connector for the conduit and the box or enclosure. There are various types of connectors available, including set screw connectors, compression connectors, and threaded connectors. The choice of connector depends on the type of conduit, the environmental conditions, and the desired level of mechanical strength and watertightness. Proper installation of connectors is essential for ensuring a secure and reliable connection. When terminating conductors in boxes or enclosures, it's important to leave sufficient slack in the wires to allow for future connections or modifications. The NEC specifies the minimum length of conductor that must be left in boxes. Leaving too little slack can make it difficult to work on the wires in the future. The type of wire connector used also affects the amount of slack required. Some types of connectors require more slack than others. Proper wire management is essential for a neat and organized installation. In addition to electrical considerations, there may also be structural considerations when installing conduit. Conduit runs must be adequately supported to prevent sagging or damage. The type and spacing of supports depends on the size and type of conduit, as well as the load it will be carrying. In some cases, it may be necessary to reinforce the structure to support the weight of the conduit. It's important to consult with the structural engineer if there are any concerns about the structural integrity of the installation. When working with conduit, it's important to be aware of the potential hazards. These hazards include electrical shock, falls, and injuries from tools or equipment. It's essential to follow all safety precautions and to use the proper personal protective equipment, or PPE. This includes wearing safety glasses, gloves, and appropriate footwear. It's also important to be aware of the location of overhead power lines and other potential hazards. Safety should always be the top priority when working with conduit. Proper documentation is essential for any electrical installation, including conduit systems. This documentation should include a detailed plan of the conduit layout, as well as a list of all materials and equipment used. It should also include records of all inspections and tests performed. Proper documentation not only helps with future maintenance or modifications, but also provides evidence of compliance with applicable codes and regulations. Remember to always consult the latest edition of the National Electrical Code, or NEC, for specific requirements and guidelines related to conduit installation. The NEC is updated every 3 years, so it's important to stay current with the latest edition. Continuing education courses and training programs can also help to improve your knowledge and skills in electrical work. There are many resources available for learning more about conduit installation. These resources include books, articles, websites, and training courses. The more you know about conduit installation, the better equipped you will be to perform safe and professional work. One important aspect to remember when installing conduit is to ensure that all cuts are clean and free of burrs. Burrs can damage the insulation of the conductors as they are being pulled through the conduit, leading to shorts or other electrical problems. A conduit reamer is a tool specifically designed for removing burrs from the inside of conduit after it has been cut. Using a reamer is a quick and easy way to ensure that the conduit is safe for pulling wires. Another important consideration is the use of proper pulling lubricants. Pulling lubricants reduce the friction between the conductors and the conduit, making it easier to pull the wires through. This is especially important for long conduit runs or runs with multiple bends. There are many different types of pulling lubricants available, so it's important to choose one that is compatible with the type of conductors being used. When pulling conductors through conduit, it's important to avoid exceeding the maximum pulling tension. Excessive pulling tension can damage the conductors or the conduit. The maximum pulling tension is typically specified by the conductor manufacturer and is based on the size and type of conductor. A pulling tension meter can be used to measure the pulling tension during the pulling process. Another important aspect of conduit installation is proper labeling. All conduit runs should be clearly labeled to indicate the circuits they serve. This makes it easier to identify and troubleshoot circuits in the future. Labels should be durable and weather resistant and should be securely attached to the conduit. Proper grounding and bonding of conduit systems is essential for electrical safety. Grounding provides a path for fault current to return to the source, which helps to protect people from electrical shock. Bonding ensures that all metal parts of the electrical system are at the same potential, which reduces the risk of electrical shock. The NEC specifies the requirements for grounding and bonding of conduit systems. When installing conduit in concrete, it's important to protect the conduit from corrosion. Concrete can be corrosive to some types of metal conduit. PVC conduit is a good choice for use in concrete because it is non-metallic and resistant to corrosion. If metal conduit is used, it should be coated with a corrosion-resistant coating. When installing conduit in areas subject to physical damage, it's important to protect the conduit from impact. Rigid metal conduit, or RMC, is a good choice for use in these areas because it is strong and durable. The conduit can also be protected by installing it behind barriers or guards. When installing conduit in hazardous locations, it's important to follow the requirements of the NEC. Hazardous locations are areas where there is a risk of explosion or fire. Special types of conduit and fittings are required for use in hazardous locations. It's also important to ensure that all electrical equipment in hazardous locations is properly rated for the environment. When working with conduit, it's important to use the proper tools. This includes conduit benders, conduit cutters, conduit reamers, and fish tapes. Using the proper tools makes the job easier and safer. It's also important to maintain the tools in good condition. When storing conduit, it's important to protect it from damage. Conduit should be stored in a dry location and should be protected from the elements. It should also be stored in a way that prevents it from being bent or crushed. When transporting conduit, it's important to secure it properly. Conduit can be heavy and can pose a hazard if it is not properly secured during transport. It's also important to avoid dropping or dragging the conduit, which can damage it. When disposing of conduit, it's important to do so properly. Metal conduit can be recycled. PVC conduit can be disposed of in a landfill. It's important to follow all local regulations for disposing of conduit. The difference between trade size and actual size is particularly relevant when using conduit fill calculators. These calculators help determine the maximum number of conductors that can be safely installed in a given size of conduit. Always use the actual inner diameter of the conduit when using these calculators to ensure accurate results. Choosing the right size of conduit is important for both safety and functionality. Undersized conduit can lead to overheating and damage to the conductors, while oversized conduit can be unnecessarily expensive. Consider the number and size of conductors, the fill requirements of the NEC, and any future needs when selecting the appropriate conduit size. Proper selection ensures efficient and reliable operation of the electrical system. Remember that electrical work can be dangerous, and it's essential to follow all safety precautions when working with conduit and electrical systems. If you're not comfortable performing the work yourself, it's always best to hire a qualified electrician. Safety should always be the top priority. In conclusion, understanding the difference between conduit trade size and actual inner diameter is crucial for safe and efficient electrical installations. By using the actual inner diameter for calculations, selecting the right size and type of conduit, and following all applicable codes and regulations, you can ensure a reliable and compliant electrical system. The historical reasons for the discrepancy are interesting, but the practical implications for modern electrical work are what truly matter. Take the time to understand these concepts, and you'll be well equipped to handle any conduit-related task.